Hey everybody, welcome to your first video in Advanced Algebra and Trig. Hope it goes well. Try to keep these as short as possible. Feel free to stop it anytime you need to. Jot down your notes that you need and save us some time tomorrow in class. So here we go. Today's lesson, types of real numbers and also interval notation. All types of real numbers. And the first part of your assignment tomorrow is going to be to name the types or give the best description you can for a real number. Every number is real with the exception of imaginary, which we'll get to a little bit later, that you probably heard about in Algebra 2. Broken down into two categories, rational and irrational. Rational numbers are numbers that you can write as a fraction. They could be numbers like 2/3 or even a decimal like 0.25 or 2500ths, because you can write that as a decimal, as a fraction, sorry. Even whole numbers such as 4, you could write 4/1, 8/2. Irrational numbers are numbers that you cannot write as a fraction, and those are kind of weird, but they're special numbers like pi. Maybe you've heard of the number e before. Things like that. Also, square roots that you don't know, such as square root of 2, square root of 5. Any square root that you cannot take the square root of is irrational. Rational numbers get broken down into two categories. Fractions, which are like the 2/3, the 0.25. Integers, which would be like the 4, 5, 6. Integers also include negative numbers like -2, -3. So if you look at how it gets broken down, how integers get broken down, two areas. One is negative numbers. They do include negatives, which would, start at negative infinity, ... -4, -3, all the way to -1. And then the whole numbers actually begin with 0 and then go positive, 0, 1, 2, 3, 4, ... They go and go and go forever, but the smallest one is 0. So integers are broken down into two categories, negatives and wholes, and whole numbers are broken into two categories also. Whole numbers broken into 0, which is kind of a very weird number, which we'll talk about more of that in the class, and natural numbers. Natural numbers are known as counting numbers. When you count things, you don't start at 0 and go, that's 0, 1, 2, 3. You always start at 1. So natural numbers are everything except for the 0, and they're all positive, 1, 2, 3, 4, and they include no fractions, no decimals. Notice, I should have brought that up here. Once you get to the integer side, once you get to integers, there's no fractions or decimals all the way down here. They stop right here at the fraction box. Let's just see if we can name some numbers. The 78 right here, the best name you could give that would be a whole number because it is 0 or greater. -9 is an integer. Both these are integers, but the best name you could give for that is just a negative number, but it is an integer. 4/5, because it is a fraction, is rational. That's the best name we can give to it. Now, one thing about this next number, the 0.34, 34, 34, 34 repeating, a lot of times there'll be a bar over the number like that. If it repeats, as long as it repeats or stops, it's a rational number. Irrational numbers, like pi, e, square root of 2 that we talked about a second ago, those numbers do not repeat. If you try to punch them in your calculator, they will not repeat, and they never terminate or never stop. So this is one of them. Square root of 2, because it never stops, never repeats, it is irrational. Irrational. All right, and the last thing today is interval notation. Interval notation, this is a great slide right here. If you need to stop the video and copy some of this down, that'd be great. Maybe you remember this from Algebra 2 also, and you're good. Couple of words here. Open looks like, I'm going to go to the graph over here. An open graph does not include the endpoints. If you notice the red area right there, not included. So what we do when we write that, if you look at the set notation, it says x is greater than a and less than b, not equal to. If there's an equal sign involved, it's called closed. It's called closed and has either brackets, or we will probably be putting endpoints on there like this, closed in. On the open ones, we'll probably put empty circles to show that it's open, an open circle versus a closed circle. Half open means part of the graph is open, a half of it's closed. Half open again, you can go either way. It can be the right endpoint closed or the left endpoint closed. Open, if just one number, it goes all the way to infinity. This one, it does not include the a, but it goes forever to the right, which means it's going all the way to infinity to the right. half open again, or half open, it's open on the right side. You can include the A. This would be, we're going to fill it in with a filled in circle all the way to the right. And the same thing is true if you go to negative infinity. Always describe these. This is one weird thing about the two last ones. We're always going to describe our graph from left to right. So when we see this one, it says negative infinity to B, it's going from negative infinity over here all the way till it gets to B. And the B has a little parentheses there. We're going to put an empty circle to show that it's open. And it can also be closed. Negative infinity all the way to B. And we're going to put a filled in circle right there. So open and close, big words there. We're going to concentrate on interval notation and also the graph. And I'm going to show you about four examples right here, and then we're going to be done for the directions here. Write the interval notation for each set and graph the set. The first one says between -4 and 5. And notice there's no equal sign. This number line is your number line. All I'm going to do is make sure you put them in the right order, but you can decide where you put your numbers, -4 and 5. Because there's no equal sign, I'm going to put an empty circle. You could also use a parentheses like was used a second ago. And I'm going to shade in between the two because that's where X is. X is between -4 and 5, open. B, X is greater than 1.7, just one number. So I'm going to go ahead and put the 1.7 on my number line. Notice it's equals, which means it's closed circle or bracket. And notice when you read it, it says greater than 1.7, so it's going to go this direction. All right, the third one, part C, says X is between -5 and -2. Remember, -5 is to the left of -2. Also, the -5 is open, no equals. -2 is closed. It does have an equals, shade in between. And then part D says X is less than square root of 5. So I'm going to put the square root of 5 on my number line, wherever you want. There's no equals, so it is open. And it says less than square root of 5, so it goes this way. Because that's the first half. The first half said graph the set. Actually, I kind of went backwards. So graph the set. The second part says to write interval notation. So I'm going to look at the number line and just write that. Part A, between -4 and 5, they're both open. When you write interval notation, you always go from left to right. So I'm going to go -4, comma, 5. That's how far my graph goes, from -4 to 5. That's a bad comma. And because they're both open, I'm going to use parentheses as my symbol. Part B, I look at my number. It's 1.7. And how far does it go to the right? It goes forever, so I'm going to put an infinity sign. Because 1.7 has a closed circle, it gets a bracket. Infinity, it never technically gets to infinity, so we're always just going to use the parentheses for infinity. So anytime you see infinity, it's going to be open. Part C goes from -5 to 2, so I'm going to put a -5 and a -2. Remember, left to right, the -5 is open, it gets a parentheses. The -2 is closed, it gets a bracket. And then the last one, part D right here, says it's going to square root of 5. But remember, we read left to right, so it's going left forever. So I'm going to put a negative infinity. It's going to negative infinity up to 5. Remember, we always leave the infinity open. And this time the square root of 5 has an empty circle, so it's also open. So I'm going to put a parentheses there. And that's all we're going to do. All right, one special case, and I promise you the video is over. How about this? How about negative infinity to positive infinity? What would that look like? Well, if you draw the number line, you can't really put negative infinity and positive infinity on the number line. So the part that would be shaded would be the whole thing. That's the whole entire number line shaded. And, kind of makes sense. Negative infinity, positive infinity, that's everything included. And remember, always parentheses around your infinities. So hopefully that wasn't too bad. Make sure you bring your notes with you tomorrow. And I'll see you in class when we work on this stuff. See you then.